Hello everyone, welcome to this video. In this video, I will show you how to model the slab, different types of slabs in Etabs. So first of all, I already created this template for this example. So if you have any question about how to set the model and set the grid line or the model section property, material property, you can come back to check my previous video. In this video, I will show to model the frame with the simple slab. So first of all, let's check the grid here. So the height, there will be only one story. So the height is 4 meter and in x direction only 6 meter and y direction 4 meter. So now let's draw our frame. So first click, I want to draw the column and the beam first. Click to elevation and draw the column. So I choose my column to be C1, which I already create the material and section. So it next. Now draw the beam. So just go to plan view and choose draw to be beam. I choose beam 2. Okay, let's say this is beam 2 and the short side is beam 1. Okay, now let's go to 3D to check our model. Okay, I will set the support to be fixed support or assign and joint restraints and choose fix. Okay. Okay, next. So now we get the frame ready. Let's draw the slab now. For slab, first we need to create the slab first. Go define and section property, slab section. So in slab, there will be, okay, let's add new slab here. And the thing I want to show is in slab, we have the reinforced concrete slab, cast in place and precast. And we also have different type like it should be fully restrained at the edge or just simply support slab. So they will classify in this category. The first one is shelving. So shelving slab is the slab that used for the structure, for example, the floor, like that. For shelving slab, they use this to analyze the structure like foundation, like how to say, spread footing, like that. And membrane is a slab that cannot trans does not share or absorb moment from the beam on the frame. So I will show you each type of this. So let's say the most common one is the precast slab. Sorry, the cast in place slab. So I'll just name this like RC slab. Reinforced concrete slab cast in place. Let's say it better. Cast in place slab. Okay, cast in place slab and the concrete we use a concrete slab and use this as a shell tint and color pink. Okay, and the thickness, we'll use the same thickness for different type of slab. Let's say it's 15. Now click OK. Now we get this, and we add another one. Just add the same similar property and name this to be pre. Let's say precast slab. I don't want to use precast. Uh should be membrane. This one is like membrane slab. Membrane is like simply supported slab. So change this to be membrane. For this, I will not. Okay, this said the same thing. Change the color to be blue. And should be use the same slab thickness. Okay. Add a copy. And for this, I will not use shell thick because shell thick is mostly used for small area and it's thick. For example, foundation slab. So this one I will name is like uh, plank slab. Plank slab is like precast slab. Plank and change the now plank slab. We use the membrane the same, but we change to use special one-way load distribution. So it's like one-way slab and same thickness. So okay, I don't want this. Okay, now we have three different type of slab. Again, cast in place. It's like monolithic slab. And membrane is simply supported slab. It doesn't matter one way or two way, depend on the dimension. But plank slab, it is only one way slab. Okay, now let's go. So let's go plan view, and we can draw slab. Click by drawing the polygon, or I want to choose the quick draw. Quick draw and choose the slab to be. Let's use the normal slab first. Cast in place. Okay, just click to the area that we want to draw. And first of all, for shell thin or cast in place slab, we need to go to do the auto mesh. So first go assign and shell and choose floor auto mesh options and choose the last one. And again, the last option, and instead of 1 meter, we change to 0.5. It doesn't, sometimes I think it doesn't really matter how you use this. It's like how fine you want the load to transfer to your frame from the slab. So if your structure is very large or many building floor together, maybe you should use the bigger number, for example, 1 or 2, in order to make it run faster. So if you use a very precise, it may take longer time. Apply. Okay, now we'll see the cookie cut. It is a mesh option. So after this, go click and assign load and shell load. Shell load uniformly distributed. Now let's use live load. So that load will be the cell weight. So I use live load 300 and apply. Okay. So before we run, just go to check the extrusion, how it look, and click OK. No, it doesn't come. Okay, sometimes when you apply something already, so it doesn't come. To make it show what you want again, just go aside and clear display assignment. Okay, now we can click again and extrude. Okay, now it come. So this the same simple slab, only one slab. So we already applied the load. Now let's run. What we okay, there will be a deformation here. But what we interest for now is we want to check how does it transfer the moment. So go to click in the moment or F8 to see, is the shortcut to see the moment diagram and choose the combination load and apply. We should go extrude first. Extrude is just to see the deformation shape. Now click OK. Okay, now we see the moment. So let's check the moment. Okay, the moment here, it's supposed to be symmetry. So on both sides, the 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 length and slab are the same. Wait. I will close this. Okay, the long side is 7 ton. Let's check is it the same? Yeah, it's same. So it's supposed to be correct. And short side 3.8 ton. This one. Okay, both sides are same. Okay, now this is like two-way slab. We can see the deformation again. F7, oh sorry, F6. Okay, this kind of deformation we can check like how the stress distribute. Okay, uh, next, uh, please remember that remember the moment because I want you to compare different type of slab. So this moment, right? And check. Okay, let's remember this is 7 ton and this short side 3.8 ton around that. Now let's change to another slab type. So this is it's like a uh, reinforced concrete slab cast in place and it cast monolithically with the column and beam. Now let's go plan view again and draw the slab. But now we will draw it as a simply support slab. So we're gonna use the membrane and click quick draw and then escape this command. So for membrane we don't do the auto measure. Now we just apply the load. Apply shell load and uniformly distributed. Okay. Now let's run. Okay, so I want to show 3D. So for the membrane, uh, we don't care how to say it doesn't analyze the deformation of the slab. It only analyze for the beam and the column. Assume because it's like assume you just put one big shell on the beam and column. So they don't consider about the slab for the membrane. And now check the moment, but the moment the load should be still transfer. So now let's check the combination load. Okay, we can check now. So the load is still 7 ton, but it's increased more. So you can see now that the moment in the maximum moment in the middle is 7.8 8.5 ton. The earlier one is 7. Oh, I think I should. Okay, the early one is 7.1 ton about. Okay, you can look back again. I remember it. And for the short side, now it's increased. Now it is 3.3, sorry, about 3 ton. Okay, you can see that the moment transformation, it will uh, change. Basically, in this case, the moment here should be larger than the the previous one, the shelving. Okay, next, I want now we see both moment already for uh, shelving and membrane already. Now let's try the slab, one way slab. So to draw one way slab, we do the same, go plan view and draw slab. Choose plank slab, plank slab, and click to the square. But in plank slab, it will show the direction. You can see this line in the middle is showing the direction. But what if we don't want this direction? We can change to the other direction by clicking the slab, select the slab, and there are two options. You can right click on it and go to local axis, go assignment, the object data and assignment, and choose local axis 2, change the default to be 90 and click OK. Now it changed the direction already. Or the other way, just select the slab and go assign shell and choose local axis. Now change to the angle that you want. Maybe sometimes you can do trial and error to see. So in this case, if we apply 0, it will go back to this direction. So I want to use 90 degrees in order to make it in this direction. So close. Now we apply the load. Shell load uniform. The load gonna be the same. Okay, now let's analyze. Okay, so if we go 3D, again, this also a kind of membrane, but in the special way, it is one-way slab. So it will also not show the deformation of the slab because I think it's like they already designed separately and uh, come to combine with the structure cast in place here. That's why they ignore the deformation. And next is to check the moment. Now let's check the moment. Okay. If it's one way slab, that means the long side here should be larger. The moment should be larger than the two previous one. So now the moment increased to 8.4 ton already. Before it just 7 point something ton, right? So by theory, uh, it's supposed to have more moment now because we change the load distribution to only one direction. And the short direction, it simply only support the salvage of the beam. This moment only salvage because the load from the slab will all transfer to this direction and the same like this. Okay, I think now you have the idea of each different type of slab you should use in your design. So maybe uh, if you compare with the theoretical one, maybe you should use membrane slab, or if it is a precast slab, you should use one-way slab. Basically, there are only three type for the simple model. Okay, so it's up to your choice which model you would like to consider. So this is the end of this video, and I hope to see you in the next video. Thank you.